Hello and welcome. In this video, we're going to talk about how to solve first order linear differential equations using the integrating factor method. So what exactly is this integrating factor method? The very first thing you need to know is that your differential equation must have a particular pattern. So your differential equation must look like this. dy dx plus py equals to q. So you can be asked to solve dy dx plus 9y equals exponential 2x. When you're asked to solve this differential equation, what comes to mind is the integrating factor method because it follows this pattern. Okay, so comparing, let's say this is equation 1 and this is equation 2. Comparing equation 1 to equation 2, I can say that p is equal to 9 and q is equal to exponential 2x. Okay, so what is the integrating factor? The integrating factor is a very simple formula. Exponential integral p dx. So once you've gotten your p, you substitute it into this formula to obtain your integrating factor. So my integrating factor becomes exponential integral 9 dx, and it becomes exponential. When I integrate 9, I have 9x. Okay, so now I've gotten my integrating factor. The next thing I need to do is to multiply each of the terms by my integrating factor. So I'm going to have exponential 9x dy dx plus exponential 9x times 9y is equal to exponential 9x times exponential 2x. So I've multiplied each of these terms by the integrating factor. Now, the solution to the left hand side of this equation right here, will always be d dx of y times the integrating factor exponential 9x. So when I differentiate this, right, I'm going to get this. So my left hand side will always give me this. Alright, so it will always be d dx of y exponential 9x. If I get my integrating factor to be exponential 5x, it will be d dx of y exponential 5, whatever my integrating factor is. Alright, so this will be equal to exponential 11x. Okay, so from this we can derive a formula that we can use to solve problems like this in a much faster way. Alright, so from here I can say that y times the integrating, or let me integrate both sides first. So when I integrate both sides, what do I have? When I integrate d dx, I will be left with y exponential 9x. Alright, and that will be equal to integral exponential 11x. So from here, I can derive a formula and say y times the integrating factor is equal to integral, what makes up exponential 11x? Exponential 9x is our integrating factor. Exponential 2x is what? Q. Alright, so we have integral of the integrating factor multiplied by q. Alright, so let's come to this corner here and put the formula. We're going to use this formula to solve the next question. Okay, so y times integrating factor equals integral integrating factor times q. Alright, so let's proceed solving this question. So from this point, we are pretty much done. Right, what we're looking for is y. So let's integrate this first. We have y exponential 9x equals integral exponential 11x. So it becomes y exponential 9x equals exponential 11x over 11. When we integrate this, we have this plus c. So we can divide through by exponential 9x to have y right? To have y equal to exponential 11x over exponential 9x times 11 plus c over exponential 9x. Okay, so y becomes exponential 2x over 11 plus c exponential minus 9x, and this is the final answer to the question. So let's look at one more question and apply the formula to solve it faster. So how do we solve this problem? X divided dx plus y equals x cubed. Recall that for us to use the integrating factor method, our differential equation must be in the format dy dx plus py equals to q. Okay, so here we can simplify this expression, right, by dividing through by x. So we're going to have dy dx plus y over x equals to x cubed over x. Okay, so from here I want y to stand alone and have a coefficients, right? So dy dx plus 1 over x times y, so that I can easily compare it, equals x squared. So comparing it, I can say that my p is equal to 1 over x and my q is equal to x squared. At this point, I can calculate my integrating factor to be exponential integral p dx, and it becomes exponential integral 1 over x dx, and this becomes exponential ln x. Integrating 1 over x, I have ln x, right? So exponential is the opposite of ln, so I'm left with x as my integrating factor, right? So I know my integrating factor. Now I can easily apply the formula. So the formula says y multiplied by integrating factor equals to integral integrating factor times q. And so I have y multiplied by, what is my integrating factor? X equals to integral x. What is my q? My q is x squared multiplied by x squared. And then I have xy equals to integral x cubed, right, dx. So xy equals x to the power 4 over 4 plus c. I can divide through by x rather, to have y as my subject, equal to x to the power 4 over 4x plus c over x, and I'm left with y equals to x cubed over 4 plus c x is power minus 1, and this is my final answer. In the next video, we're going to talk about Bernoulli's equation. Thank you very much for watching. Don't forget to like, don't forget to share this video, don't forget to subscribe. Thank you so much. Goodbye.